let's get it started. So today we're going to talk about writing and graphing inequalities. So we're talking about writing signs that aren't equal to something. So that's your whole goal today, that you can write and graph any inequality that I give you. So let's start off by talking about the vocabulary we need to help understand what we're looking at. There are three different types of phrases that we're going to talk about. We've already talked about expressions and equations. So in your mind, come up with the idea, what's an expression? All right, good. So you guys came up with the idea that it's a mathematical phrase, or you came up with the idea that it is a mathematical statement that does not have an equal sign, and that's correct. And I say, okay, now when I say the word equation, all right, so now you should come up with the idea of it's a mathematical sentence that has an equal sign. So it's got both parts. So if you want to go with the language arts metaphor, that has both a subject and a predicate, okay? Or a subject and a verb. And then we have our final one. Now this is our new one, an inequality. So this is an equality. This is nothing. This is an equality. This is an inequality. And an inequality is the same as an equation. It's a mathematical sentence, but this time it's with an inequality sign. Okay, so if you think about what are inequality signs, so most people easily understand and get this perfectly right the first time that these are an equal sign. That means it's the same. Okay, an inequality sign, and we talked about these as in class, is one of them is the idea that this one is not equal to. That's what that stands for. So while this first one is equal to, this is not equal to. But then we have four other inequality signs. You've been exposed to greater than and less than. Today we're going to take a look at adding two more to that list. We have greater than or equal to and less than or equal to. So to kind of show the difference between that, think about riding a roller coaster. So to ride a roller coaster at a lot of theme parks, you've got to be 48 inches tall. Okay, so the question is, can you be 48 inches tall? Or do you have to be 48.1 or 48.2? Or so think about when you walk up to that line, is it okay if you touch the line but not go over it? Do they still let you ride? And the answer is yes. That is the instance where it can be that 48 inches. That's where you use a greater than or equal to or a less than or equal to sign, where if it includes the actual answer. Okay? So let's take a look as we keep digging into how we do this. So this one's going to sound like I'm Mr. You're asking me to do way too much work. There's no need for me to do this. I just can know this. Well, that's great, and I appreciate that, and I get that. I appreciate that you just know it. But what I really want you to do is take a look at and talk and answer this question. Do you understand what makes the statement true? So in that problem, that's kind of what we're going to explore too. When I say what makes this inequality true, we're going to talk about what I mean by that. So if Louisa works at a gift shop and she receives a bonus if she makes more than 20 balloon bouquets a month. So which months did Louisa receive a bonus? Use the inequality B stands for where B stands for the number of balloon bouquets that she made each month to solve. So to see if this statement is true, now I do understand most of the time we do this in our head, but we're going to write it out today. Is 25 greater than 20? And you go, yeah, of course it is. So this is a true statement. Okay, if you go back to where you were in elementary school, they taught you that the mouth eats the bigger number. It's still true here. So when we look at August, where she made 12 balloon bouquets, is 12 greater than 20? No, that's a false statement. So that's wrong. So it's false. Where this one's true. We go down to September. We go 18. Is that greater than 20? No. Again, another false statement. And finally, is 32 greater than 20? Yes, it's a true statement. And again, a lot of this time you're going to do this in your head, but the idea, understanding when a teacher says it is a true statement, what makes this inequality true, they're just asking you which one is correct, that where that statement is the number to the left of the other or to the right is greater or less than, depending on the inequality sign. So you would tell me the answer, though, to this one would be July and October. She received her bonus for making more balloon bouquets. Go ahead and give this next one a try. Pause the video, see what you come up with. All right, now that you've taken a look at your inequalities and go, okay, when is C greater than 65? Well, is 43 greater than 65? You're like, Mr. Melody, that is not it. So is 66 greater than 65? Definitely that's a true statement. And we know 37 is not greater than 65, so this is not a true statement. So the only day that more than 65 cars came would have been Wednesday. Okay? So there's our final answer, but we're taking the time to take a look at the idea of a true statement. All right, so let's take a look at these. Now, these are the next two practices because we're going to look at how do we write an inequality when we're given words. So, and how do we write this and how do we think about this? All right, so write the inequality for this sentence. You must be over 12 years old to ride the go-karts. So if we're looking at this question, we got to look, okay, first things first, we have a word problem, so we need a let statement. Let's say X is equal to age. It's a good short word to write. So now that I've got this, and I'm always going to use X in this case, and we're going to see why when we graph it, because not normally, 99% of the time we're graphing an inequality on a horizontal number line, so X is that horizontal axis, so we're going to use X a lot of times. So if we go X, you must be over, so they're talking X has to be greater than 12 years old. So you have to they're really saying you have to be 13, okay? Another way they could say this is you have to be 13 or older to ride the carts. And that would be a different sign because you could also be 13. So you'd have that inequality with the greater than or equal to sign. A pony has to be less than 14.2 hands. That's what the definition of a pony is. So we're going to say X is their height because that's what hands measure. Pony's height or a horse's height. So we're going to say this time it's X is less than 14.2 hands. If they're 14.2 hands, they're technically a horse. Okay, go ahead and pause the video and see if you guys can get these and get the inequalities written for these two statements. All right, let's see what you came up with. So you have X is the cost to ride a Ferris wheel. Here you have X is the weight of the pig. Okay, we've got those X's out of the way. X must be greater than $5. Put my dollar sign so I'm being perfectly correct. And here we say X must be less than 220 pounds. All right, so we've got a great head start on kind of writing inequalities and reading them and seeing if there's true, creating an inequality. Okay, now we're going to look at the next piece and how do we graph, let's take a look at a real life situation. So let's talk about, a lot of these are where we're going to talk about the idea of the greater than or equal to or less than or equal to situation. So for example, write an inequality, you must be at least 16 years old. So if we're thinking about at least to drive a car. So we're going to go X is age again. Okay, so if I'm at least 16 years old, the question I'm going to ask myself is, can I be 16? If I can be 16 and drive the car, I'm going to say X can be greater than or equal to 16. Because that's the case, because at 16 years old, your birthday, the very day you're born, you can drive a car. Okay? Take a look and pause the video and see if you can write the inequality for this next this sentence. You must be at least 15 years old to take adult swimming lessons. All right, now that you've got that done, we'll say X is equal to age again. Oh, I love it when there's the two same light statements. So X, in this case, you must be, if you're at least, you have to be greater than or equal to 15 years old. Put the label on this time. Okay. Now, as we keep going through this, let's take a look at now the next step is, can I graph the number line? How do I graph this? How do I put this in a visual idea? Because up until now, one of the things we learned about at the very beginning is that there can be more than one answer to an inequality, where an equation, there's only one answer. But inequalities have these huge frames of reference, these huge answer banks that are possible. Anything that makes that statement true answers the inequality. So a number line gives me that visual representation. So these are n, so they're going to use n, but that's okay. We're going to draw a number line. And when I'm asking you guys to draw a number line, I don't need a very long or very, very drawn out specific number line. I'm going to ask just for three simple numbers. The actual number in the inequality, one number above, and one number below. So that we can talk about, okay, do you know which ones are greater or less than? So you can have that in there. So we're looking at this. So n, to make the statement true, the number over here has to be greater than 9. So can it be 9? No, it can't be 9. It's got to be greater. So it can be every number to the right of 9. So it could be 9.1, 2, 3, and any rational number inside that box, all the way up to infinity, to the largest possible number. Now, if we take a look at this inequality, same idea, but now we have a slightly different thing. You're going to say, why did you use a dot that's open? Well, that's a great question. When I'm using a greater than or a less than inequality symbol, I need to use an open dot to show that that number is not included in the problem. Where if I come over here and use a greater than or equal to or a less than or equal to, I use a closed circle, a filled in circle, to show that that number is part of the answer. Okay? Just like the line is filled in, we show that that's part of the answer. So if I do my same number line here, I got to make it a little bit different though, because 10 is in the middle, 9 is over here, and 11 is over here. We're going to say, okay, it's great. So we've got that. We know it's at 10. Does it include 10? No, it's less than or equal to 10. So it's this number here. It includes 10. Now, want to see this really neat? Well, I won't show it to you yet. I'll talk to you about it after you try your problems. So go ahead and graph these two and create a number line and graph these two problems while the video is paused. All right, let's quickly make our number lines. So we've got 6, 7, and 5. We've got an open circle again, and it's going to go towards the left is less than. All right, now we make our second one. We have n is greater than or equal to 5, so we're going to make a very similar number line, 5, 6, and then 4 over here. This time we have a closed circle, and we go to the right. Now, I don't know if you guys have taken a look. It's a really neat process about math and how cool it is that it's logical, is that look at my inequality and look at the way the arrow is drawn on my graph. They're going the same direction. And anytime you have that variable first, that's how that's going to work. Now, if you have them flipped, it goes the opposite direction, and that kind of makes sense. But if you have variable inequality sign, then the number, the inequality is going to point the way to graph. That's a really neat, logical piece that math has built into it. So the last thing I want to look at are these two more real life situations, because a lot of real life situations, it is just like we talked about. It's going to be greater than or equal to, not just greater than or not just less than, or not. It's going to include that number a lot of times. So as we build this question, this time it says, I want you to do everything I've done in this one lesson. Write and graph an inequality to describe the possible speeds on this street. Okay? So if traffic on the residential street can travel no more than 25 miles an hour. Okay, so we're going to go ahead. First things first, we're going to say let x equal speed, or miles per hour. Okay, we're going to create our graph because we'll need it. And then we're going to do, all right, so x, we're going to use x for our speed. X and 25, can they drive faster than 25? No. Can they drive 25? Yes. So can they drive less than 25? So since I've said yes on both same speed and less, I know I'm going to use less than. This time I'm going to change my scale a little bit. 25, 30, 20. Less than 25 means I have that same closed circle going to the left. Go ahead and pause the video and graph that situation we talked about earlier today. You have to be 48 inches to ride a certain roller coaster. Right? And graph the inequality. All right, so once again, we're going to say x is their age. That's my favorite x's today. So create our number line. We'll draw out the numbers in a second and say x, and we're going to put 48. So you have to be at least 48 inches tall. So my question is, can you be less than 48? No. Can you be 48? Yes. Can you be greater than 48? Can you be 62 inches, for say? And the answer is yes, so you're going to say it's greater than or equal to. So again, we're going to do 48. This time we'll do 50. We'll change our scale up a little bit, and 46. So we're going to have that closed circle. This time it's going to be pointing towards numbers that are greater than 48 inches and including 48. So that gives you everything you need to kind of prep for this lesson and to understand the different parts of writing and graphing an inequality. If you have questions, please come. Feel free to come in and see me, and I will talk to you guys later in the next lesson. Have a great night.